Welcome back, chemistry friends. All right, today what we've got is our last homework on this unit, and I believe it is part 8, unit 2, part 8, I think is what we're doing. So let's jump right into it. Let me share my screen. We've got a couple of questions that deal with these last little topics, such as polarity and bond strength. Okay, so let's get into it here. Get that down there. So SO3 is our molecule. What's the name of this thing? Well, first off, we need to look at what the atoms are. That should be our first task whenever we get into these naming routines. So sulfur and oxygen are both over on the right-hand side. They are both over here. And so they're both nonmetals. So their naming routine is going to need to have prefixes. And it's SO3, so we will do monosulfur or just sulfur. And since there's 3 oxygens, we should call this trioxide. Now, if you want to drop the vowel on that one, just call it tetroxide. That's fine. It might get confused with tetraoxide. So generally speaking, in this case, they just do a trioxide. Anyway, doesn't matter. I can understand what you're trying to accomplish if you just give me that portion of it. Now, with this also, we're going to need to draw our Lewis structures. We need to see that both S's and O's have 6 valence electrons because they are in the 16th column of the periodic table. So we are going to use that now to draw our Lewis structures, and then we'll figure out all the resonance shapes of this one. So first element always goes in the middle. I've got my oxygens around here. I'm going to do want minus have. So my want, there are 4 atoms that each want 8. Let's scribble this out. And that's 32. The have, in this case, is 4 of them. They each have 6, and that's 24. Subtract that difference, and you have 8. Divide that by 2. That means there are 4 bonds. So somewhere in here, we've got to have a double bond. So here's where the resonance structure comes in, because you then can draw this in one of 3 different patterns. You could put that double bond on the left, on the top, or on the right. 3 different ways in which you can have this. There are no extra electrons because the sulfur has already established its stable octet. Okay. The shape for this one, because it has no extra electrons, it lays flat on here. This is trigonal planar, not a planar, not 2 M's. What is the bond angle? Okay, so if we have a circle and we divide it evenly into thirds, what that means is you would have 120 degrees. I know that looks like 128 because I have a hard time drawing this. It is 120 degrees is what that is. And so that's our bond angle in between each of these materials. I've got something flying around my head here trying to eat me. What is the bond angle? Got it. What is the size, shape, and ionic character polarity of this molecule? I tried to kill it again. So what we're going to have to figure out, size and shape and ionic character. Because this is symmetrical, 120 degrees around it, and it's not at a 3-dimensional, it's not like a trigonal pyramid. This one, according to shape, it is going to be nonpolar. According to size, now these guys are on different energy levels on the periodic table, so that will tell you that it is polar. As far as ionic character is concerned, I'm gonna have to go and look that up. So hang tight. Let's go and open up a new slide here. Ionic character chart. Let's see if we can find one. Here it is. And it looks like oxygen 3.5, sulfur 2.5. There's a difference of 1 betwixt those two. So 3.5 minus 2.5, that gives us a 1.0. That's slightly larger than nonpolar. So according to ionic character, we're talking polar covalent. It's not 2, it's not 2.5, it's not big enough for it to be completely ionic, completely polar. So it's somewhere in between it. They're pretty close still. All right, circle the shortest bond in the molecule. The shortest bond is going to be the bond that has the double bond. The double bond is by definition going to cause it to pull in tighter. And so there's where we circle and then highlight the shortest bond. The shortest bond is also the exact same as it was for the double bond. So the shortest bond is going to be the one with the double bond. So just practicing what we've already learned in class. Thank you very much for your time. Hopefully you guys are going to get prepared for your test. Talk to you again soon. Bye-bye.